Today we're going to be talking about the distributive property and combining like terms. We're going to start first with a vocabulary. A variable is just a letter that represents an unknown value. The most common variables we use in Algebra 1 is an x and a y. A coefficient is a number that's just being multiplied by a variable. So for example, if I give you the expression of 2x, 2 is my coefficient. It's being multiplied by the variable x. Like terms are just terms that have the same variable and same exponent. Both must be the same for them to be like terms. The distributive property is just a property that allows us to simplify an expression by using the operation of multiplication. So for example, if I take a number, let's say 2, that's out in front of a parentheses, I can multiply it by everything inside of the parentheses. A polynomial is just any expression that consists of numbers, variables, and exponents. If you think about this, this is like a broad term that covers many different types of expressions. This is similar to how the term polygon describes any type of closed figure that doesn't have curved sides. Then you have different types of polygons like a rectangle, a triangle, a pentagon. Well, polynomial describes all types of expressions, no matter the number of terms. And then we can get specific on the type of polynomial based on how many terms they have. So we have 3 different types of polynomials. The first is a monomial. A monomial just simply describes a polynomial with a single term. The prefix mono stands for 1, just like a monocycle is a bike with 1 wheel. A binomial stands for 2 terms, similar to how a bicycle just means a bike that has 2 wheels. The prefix bi stands for 2. And last vocab word for today is trinomial. This is a type of polynomial that has 3 terms, similar to a tricycle, which has 3 wheels. The prefix tri stands for 3. All right, so now let's take a look at some examples. First thing we're going to do is label each polynomial as either a monomial, a binomial, or a trinomial, based on how many terms I see in each expression. So looking at number 1, I'm going to first look for addition and subtraction signs because remember, terms are separated by those. So my first term is the 5x and it stops right before that addition sign. My second term picks up there and goes to the next addition or subtraction sign. So 2y is my second term, and then my last term would be that -6. Notice I have 3 separate terms, so this is going to be a trinomial. Number 2. Notice I don't have any addition or subtraction signs between the -5, the x, the y, and the z. They're all pushed together, so that makes one single term. So that makes it a monomial. All right, last example like this, number 3. Notice again, we split it in between where we see the addition sign. So our first term is x squared, and then we have another term at +7x. That makes this 2 terms, which makes it a binomial. Okay, on this next section, we just want to create terms that are like terms to the ones that are provided. And so remember, for it to be a like term, it has to have the same exact variable and the same exact exponent. So for number 1, any like term that I see has to have an x squared on it. It does not matter what the coefficient is, it just matters that it has an x squared. So I could use x squared as a like term, which remember that means there's a 1 coefficient in front. I could say -4x squared because it has an x squared, it's a like term. Or I could say 10x squared. Again, all of these are like terms because all of them contain x squared. All right, for number 2, any like term that I want has to have an x to the first power and a y to the third power. So a couple of examples of this could be, let's say, negative 2xy cubed, or I could say 14xy cubed. Again, for it to be a like term, it has to have that xy cubed. Anything that has that is a like term. Now, to be a like term with a whole number -6, it just means it can be any other number that has no variable at all. So for example, I could use the number 0 as a like term, the number 11 is a like term, or the number -7 is a like term. And number 4, to be a like term, it has to have a single x tacked onto it. So a couple of examples of this could be, let's say, -7x. We could say a +2x, or we could say just the variable x, which remember means it has a coefficient of 1. Again, for it to be a like term, all it needs is a single x on it. It does not matter what the coefficient is. Okay, now that we've talked about what like terms are, now we're going to actually simplify an expression by combining the like terms together. So we're going to then label the answer as what type of polynomial it is. So looking at number 1, I see a 5x and I see a +3x. Both of those are like terms because they both have an x. So if I combine those together, all I'm basically doing is adding the coefficients. So 5 plus 3 gives me 8, and I keep my x the same. I also have a set of like terms with the whole numbers. So I have a -12 and a +2. If I combine those or add those together, that leaves me a -10. I cannot combine 8x and -10 because they're not like terms. So this would be my final answer. Now, since I see two separate terms, that's going to make this a binomial. Okay, on number 2, I see a -8x squared and I see a +3x squared. So again, that means I'm going to combine those coefficients. A -8 and a +3 is going to leave me a -5, and I tack the like term of x squared on it. Then I look for the next set. I have a +5x, but I have no other x's to combine with that, so I'm just going to drop it down to my answer. And last, I have a -6. Again, I have no other whole numbers to combine with that, so I'm going to drop it down. This would be my final simplified expression. For this expression, I see 3 individual terms, so that makes this a trinomial. Now that we've talked about combining like terms, we're going to switch gears and look at the distributive property. Now remember, this is where I use multiplication, and we use this in the event that I cannot combine any like terms that are inside the parentheses. So if I look inside of this given parentheses, I have an x and a -2. If you notice, those are not like terms, so I cannot do anything with them. It's already as simplified as I possibly can. So when this happens, I actually take the value that's out in front of the parentheses and I multiply it by every term inside the parentheses. So I'm going to look at this box right here. This is actually the rule of what distributive property says. It says I can say A times B, which gives me AB. I just push those two variables together. And I can say A times C, and I just push those two variables together. And that would be my simplified expression using the distributive property, since I wasn't able to add the B and the C together initially. So let's take a look at simplifying some expressions using the distributive property. So number 1, I'm going to take that -3 and I'm going to multiply it by x. Whenever I multiply, remember I just push the 2 together, so I get -3x. We always put the number in front of the variable. Then I also do -3 times 1, which gives me -3. I cannot combine these two because they are not like terms. They don't both have an x variable. And remember, I did this process since initially I could not add x plus 1, so that required me to use the distributive property. This is a fully simplified expression, so that is my final answer. Number 2, I know it doesn't look like I have a number there, but remember, if I don't see a number, that number is a 1. So I am going to actually distribute a -1 to both pieces inside the parentheses. So -1 times x just gives me -1x, which we write as -x. We just push them together. And then we have -1 times -4, which gives me +4. These two things cannot be combined because they're not like terms, so this is my simplified expression. Number 3, I cannot combine anything inside the parentheses because they're not like terms, so I'm going to apply the distributive property. I'm going to do 1/2 times 2x. Well, 1/2 times 2 gives me 1 whole, and so I just have 1x, which is the same thing as x. Then I do 1/2 times 6z. Half of 6 is a +3, and I tack on my z. And then 1/2 times -4, well, half of -4 is -2. Again, I cannot combine any of them. None of them are like terms since they don't share a variable in common with the same exponent. All right, number 4 is a little bit different. Do you see how I have 2 sets of parentheses? I check inside the first parentheses. I can't combine anything. They're not like terms. Second set of parentheses, can't combine anything. They're not like terms. So I'm going to do the distributive property. On this problem, I'm actually going to do it twice. I'm going to distribute a 7 to the first set of parentheses. So 7 times x gives me 7x. And 7 times 4 gives me a +28. Then I'm going to also distribute this -6. Now this is really important. The negative sign has to go with the 6 when I multiply. This will cause you to get your answer wrong if you do not take the negative sign with it. So I like to always circle it so I remember to take it with it. So -6 times 3 gives me a -18, and -6 times -y, remember, a negative times a negative gives me a positive. Remember, if you need to, you could put a 1 there. That would give me a +6y. Now I'm going to look for any like terms. There's no other x's to combine with the 7x, so I'm not going to worry about that. There is 2 whole numbers I can combine, the 28 and the -18. So that means that is going to combine to give me a +10, and there's no other y's to combine, so I'm just going to drop it down. That's my simplified expression. One more example of this. Again, I have 2 sets of parentheses. If you look inside the first one, can't combine anything, there's no like terms. Look inside the second, can't combine anything, there's no like terms, so that means I have to apply my distributive property. I'm going to distribute 4 to the first parentheses. I'm going to do 4 times 3/4. Remember, I can use my graphing calculator to do this. I'm just going to type in 4 times alpha y equals will get me a fraction in the calculator. And I'm going to type in 3/4. That would leave me a 3, and I tack on my x. 4 times 2 gives me a +8. Remember, when I go to distribute the second time, I have to take the sign with it, so I'm distributing a +5. 5 times 4/5. You can also think of this as 5 times 4 and then divide by 5. So that's going to leave me a 4, and I bring down my x. And 5 times -1 gives me -5. I look for my like terms. I have 3x and 4x that can combine together to give me 7x. And I also have a +8 and a -5 that are like terms that come together to give me a +3. I cannot combine these two, they're not like terms, so this is my simplified expression. All right, now we're going to explore why does the distributive property work? And so I'm going to show you 2 problems where I'm going to do it both by order of operations and by distributive property. So if I look at question A, I have 3 parentheses, 4 plus 2. I'm going to first solve this using order of operations. Well, remember, in order of operations, the first thing I'm going to take care of are my parentheses. So I'm going to do 4 plus 2. 4 plus 2 gives me 6. So I leave it in parentheses because it's showing the multiplication by the 3. So then the last thing I do is 3 times 6, and that gives me 18. Now I'm going to approach the exact same problem, but this time I'm actually going to do it by distributive property. So I'm again going to copy the problem down. I'm going to distribute 3 times 4, that gives me 12, and I'm going to do 3 times 2, which gives me 6. Now if I combine like terms, 12 plus 6, I get 18. Do you notice that it's the exact same answer? So technically, if I have a problem where it's all numbers in the parentheses, I could actually choose which method I want to do it by. Now, it's typically a whole lot easier to do it as order of operations, but I could technically do distributive property if I wanted. Okay, so let's try one more just like that. So I'm going to take the problem 2 minus 4 parentheses 7 plus 3. I'm going to do it by order of operations first. So first thing I'm going to do is simplify my parentheses of 7 plus 3. 7 plus 3 gives me 10. Remember, next I need to do exponents, but I don't have any. So then I go to multiplication division. I do have multiplication. I have negative 4 times 10, which gives me a negative 40. And then last, I would do my subtraction, 2 minus 40 to get negative 38. Let's look at that same problem through the lens of distributive property. Now, if I were you, I would flag this problem. A lot of people make mistakes on it. When they want to do this problem, for some reason, they always want to do 2 minus 4 first. Well, I want you to think about this. You can't subtract before you multiply. And remember, the distributive property is multiplication. So what I'm actually going to do is I'm going to drop the 2 down. I'm not going to do anything with it yet. I'm going to distribute the negative 4, so it means multiply, the negative 4 by everything in the parentheses. So negative 4 times 7 gives me negative 28, and then negative 4 times 3 gives me negative 12. Then I'm going to do my subtraction in order from left to right. So I'm going to do 2 minus 28, which gives me negative 26. And then I'm going to do negative 26 minus 12. And what do you notice? I end up with negative 38 again. If I've done it correctly, it doesn't matter order of operations or distributive property, they'll both come out to be the same. All right, I have one more example I want to show you. And this is a word problem. It says an artist uses a rectangular canvas that has a length of 4x plus 3 and a width of x plus 2. First, it just wants me to draw a picture of the canvas and label all 4 sides. So the first thing I'm going to do is draw a rectangle, and I'm going to label all 4 sides. So we know about a rectangle that opposite sides are congruent. So I label the top and bottom 4x plus 3, and I'm going to label each of the 2 sides x plus 2. Now, part B wants me to find the perimeter of the canvas. If you remember from middle school, perimeter is just adding all the sides. So technically, if I wanted, I could write this out. I'm going to say x plus 2 plus 4x plus 3 plus x plus 2 plus 4x plus 3. So I'm just adding all 4 of those sides together. You can kind of see the 4 sides right here if it looks kind of confusing to you. Now I'm going to look for like terms that can be combined. So I have an x, I have a 4x, I have an x, and I have a 4x. So remember, these single x's have a coefficient of 1. If you need to, you can write those in. So 1 plus 4 gives me 5, plus 1 more gives me 6, plus 4 more gives me 10 x's. And then I'm going to look at all of my whole numbers. I have 2, plus 3 gives me 5, plus 2 gives me 7, plus 3 gives me 10. So that's my perimeter.